Hello everyone, welcome to this new video where we are going to dive into walking robot simulation. So basically in this problem we receive as input a given list of obstacles and we receive a given list of command or instruction, and you're supposed to kind of guide the robot to move respecting the given instruction, and whenever you find an obstacle you just stop. So it's just like a simulation problem where you kind of narrow the robot, and the goal here is to find out what is the maximum distance the robot can move from the initial point, which is actually 0 0. This is your starting point. So basically this is what the problem is about. Now to understand it better, one thing I suggest is the simulation of maybe this. Why this? Because we have an obstacle and we have a list of elements, so we will understand better. So what is happening is that when you are starting, you have your robot at a given position. He's moving in I would say a given space where he can move up, left, down, and right. Sorry, up, right, down, and left. So that is what the robot can do. And initially, the robot can move up. That is important. Initially, the robot can move up. Now that we know the robot can move up, the first instruction is 4. That means the robot will move 4 steps in the given direction he is looking. So the robot will move 1, 2, 3, 4. And if the robot is moving 4 steps, this will be the final position of the robot. So at the end of this, I will say the robot will be at position. So the x hasn't changed, which is actually 0, and the u has changed, which is 4. This will be the final position of the robot after the first step. I will not explain you this that much, but you can look at it if you want. But the distance that you need to compute, just keep in mind that it will be equal to x square plus y square. Why is it like this? Is the Euclidean distance basically is the difference between the axis and the coordinate. But since we are 0 here, we know that x1 minus x2, which is 0, will always be x. So just keep in mind that this is how you are going to compute the distance. Don't bother about that. Now we are here. That means if you want to use this formula, the distance will be equal to 16 at the first step, right? Nice. Let us now, the second instruction is a -1. So what has been said here is that if you receive an instruction which is -1 or -2, that means it's a reorientation, it's not a move. So you just need to reorientate your robot. -1 is turn right. So the robot was looking like this. -1, that means the robot will now be looking like this. This will be the position of our robot. Now the next instruction is move 4 steps forward. So we are here, we need to move 4 steps forward. One thing I forgot to implement is the different obstacle. This is the obstacle of at position 2 4. Let me just take a red mark to put the obstacle 1 2 1 2 3 1 2 3 4. So this is the obstacle. We just have one, so I'll just leave it here and I continue. Now the robot needs to move. This is where the robot was. He needs to move 4 steps. This is the one move. Second move, he will not be able to proceed because there is an obstacle. So basically at this point the robot will stop here, and this is position 1 4. And this position 1 4, if I want to compute now the value, it will be, I use the formula 4 times 4 plus 1 times 1, which is actually 17. Now that I'm here, the second instruction is -2. -2 is what? It's a turn right. And turn right means that now the robot will no more look here. The robot will now looking like this. So it will, if you have move instruction, it will be moving up. So now after this, what do we have? 4 step. 4 step means we need to be able to move 4 step, 1 2 3 and the 4. Now that we are here, what is the position of the robot here? This is actually a 1 8. If you want to compute the distance, what will it give? 8 times 8, which is 64, plus 1 times 1, which is actually 65. And then what should we return? We should actually return this, because it's the biggest, this is the biggest distance we can move from our initial position. So this is actually what we should return. I hope this was kind of clear for you, and it helped you to understand more of what we are doing, where we are going. Now, from this explanation, we can move 3 key observations, which is being able to update the direction. That means you need to know if you are moving right, left, and so on. Being able to move and check obstacle. So being able to move and check if there's an obstacle. If there is one, you just need to stop. Otherwise, being able to move until you have completed all of the command of moving. And after being moved, you need to be able to compute the distance and use that distance to check if you have done more than you did before. So let me note them down. So we need to be able to update direction. We need to be able to move plus check, and then we need to be able to compute distance. Nice. Let us start now. Try to implement. The first thing I will have is I will try to have like my initial variable initialization. I didn't mention that, but we need to have it. We need to have like our output. This is the guy that is going to keep the maximum distance. So we are going to start it at 0, and then we need to have our initial position, which is a vector of int. You understand why? Position, which is actually equal to 0, 0. What does this mean exactly? It means that initially I'm here. That is it. Okay, so those are the initialization. Now, to update the direction, how will I organize myself to update the direction? Now, this is what I will do. I'll just make a remark that if I want to move up like this, there is only one element I need to update, which is actually the u. I need to update u one at a time. That means if I'm at position 0, I will say x. If I need to move up, that means the next value will be x plus 1. Make sense? That means if I want to move up, let me get this here, it will be easier for us to understand. If I want to go up, I will just add nothing to the x, and I will add plus 1 to the second position, which is actually u, for it not too confusing. And if I'm moving down, I will add nothing to the x, and this one I'll just decrement it by 1. Understand? If I'm moving to this point, so what I will do, this one will take plus 1 and this one will take nothing. And if I'm moving this way, this one will take minus 1 and this one will take 0. By having this, what can I conclude? I can say that if I can have like in element to index, then maybe 0 here. Let me take another color. Maybe 0 here, 1 here, 2 here, and 3 here. I'm sure that if my direction is actually 0, that means I know that I'm moving this direction. If my direction is 1, I'm moving this way. If my direction is 2, I'm moving this. This will help me to say, okay, I'll just keep an index of the direction I'm moving, and whenever I'm moving, I will update my position where I am with the value corresponding to the position. So if the index is 2, that means moving means updating the x plus by adding 0 and the u by adding minus 1, and the same for all of them. So for us to achieve this, what we need to have is just to create a vector of position, like a vector of position. So we are going to have that map. So we are going to call it like a vector of int that I will call moves, and I will initialize it at this, like I said, 0. The element position 0 is 0, 1. 0 I have 0, 1. 0 I have 0, 1. At 1 I have 1, 0. So you got it. At 1 I have 1, 0. at the half 0 minus 1, and the last one is actually equal to minus 1 0. So this is actually the different position, and like I said, I need to have like this guy that will be able to map those elements. When I will say, okay, my direction is 0, that means it's this element. So I will have something like in direction here that I will start at 0. Why am I starting direction at 0? Because initially I'm moving up. That is all what I need now. Okay, so this is what I need to kind of map the direction. Now let us talk about the move plus the check. Before we move, when do we move? Let me look through the command. So I'm looking through the command. For each of the command, I just need to check if the command is actually equal to minus 1. What is this about? This is actually a simple move. That means we are moving minus 1, we are moving to the right. What does that mean? That means if I'm here, I'm moving this way, it's a plus 1. If I'm here, I'm moving this way, it's a plus 1. If I'm here, I'm moving this way, it's a plus 1. If I'm here, I'm moving this way, it's a plus 1 that should give 0. So basically, when it comes to minus 1, what you need to do is just saying that direction is going to take direction plus 1. Since you know that you can, if you are 3, you need to come back at 0. 3 plus 1 will give you actually 4. You can just use the modulo operator to reinitialize element whenever you hit 4. So you just need to add this modulo 4. That is all. Now you just need to else if command is actually equal to minus 2. This is the second direction update. So this is actually a direction minus 1. You got it? So it's a direction minus 1. And since you know that you can find yourself at 0 and you try to do minus 1, to avoid being out of range, what you can do is that you can just say minus 1 plus 4. That will be a reinitializer. Minus 1 plus 4. And yeah, always add the modulo 4. Okay, so these are the two elements that you need to implement for the move. Now this else now is now for the, this is the operation you need to, this is the element you need to do for the orientation. Now this is the compute of the move. Now for the move, what I need to do is simple move from 0 till the command. That means if I want to move 4 steps, I need to move first step, second step, and so on. So for me to do so, I will just like for int a moving for 0. I hope I haven't used that before. Okay, a is less than the command, which is the number of elements I need to move, I plus plus. And for each of the element, what I need to do is to compute the new position. Vector of int will have new position, and the new position is basically equal to exactly what we said recently. How do we compute the new position? We are going to use the direction, so the new position is going to be the previous position I was in. Position, this is the x, plus who? Plus the move of the direction, because the move of the direction actually gives us how we are going to move, of 0. This is actually what the x will be. And the second one is basically this that I will retype here, position of 1 plus move of direction of 1. This is all what you need here. I hope this is kind of clear for you, and then you are understanding why we were having this mapping. And after that, after performing the move, I need to check if there's an obstacle. And for me to check obstacle, I need to have like a kind of set or a list of elements where I have all my obstacles. So I will do it here. So to do it here, I'll just say set of vector of int, and I will call it st, and for here I'll just say for auto obstacle. in obstacle, and I'll just say st.insert of obstacle. Hope is the name correct. No, I think I had a typo somewhere. Yes. So this is actually where I have all of my obstacles. So for me to check, the only thing I will need to do is just to check if my st.find of my actually new position, if the new position is actually different from the end. If it's different from the end, that means it is not. If it's different from the end, that means there's already, that means that new position is one obstacle. So I just need to break. There's nothing I will do here, and the break is just like this. That means I'm ending here. Otherwise I will find myself here. That means I can update my position with the new position. So this is actually all about being able to move. And if I found myself here, this is the end of the command. That means at this step, all of the command has been implemented. So this is where I need to compute the distance. So I'll just make it easy, saying output will take the maximum of the previous output sorry, and position of 0 times position of 0 plus position of 1 time position of 1, and this is all. So, and after this, here is the end of everything. So here I should just return my output. So I hope this was kind of clear for you. So basically what I'm doing is that I'm initializing everything here. Here I'm creating like what I will use to update my direction. Here I'm kind of creating my map of obstacle to check if an element exists. And yeah, I kind of have everything I need for the direction. How do I move? And this is where I'm applying like the move. And only because I have the command of moving, which is between 1 and 9, that I can allow myself to move one by one, because I know that 9 element is basically bigger of 1. So that's why I'm allowing myself to do something like this. Let's also run and see what it gives first, and make sure everything is green. Okay, we have an error. It's starting early, line 15, so I missed something here. Okay, everything is green. Let us submit. Yes, everything is green. So this was my approach of solving this. I hope you did enjoy it. It was really interesting to go through it. It's a simulation problem, and being able to solve this is kind of nice because it shows that you are able to, play around instruction, make robot move, and yeah, really interesting. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you on the next video tomorrow for a new challenge. Ciao.